So, we are discussing about the space quantization and Zeeman effect. So, we have seen that fine structures of hydrogen H alpha line, and then for sodium D lines D1, D2. So, that was not able to explain using the Bohr Sommerfeld model, as well as when magnetic field is applied, strong magnetic field is applied, then each spectral line is splitted into 3 lines. So, that is normal Zeeman effect, and that also not explained by Bohr Sommerfeld model. So, it seems there are more lines, means more splitting of energy levels. So, we need more quantum quantization or quantum number. So, so far what we have seen that that Pk, that is K is cross angular momentum. And what is that? This, there is a direction of this one, there is a direction of this one, and the direction its electron is rotating in a elliptical orbit, and its angular momentum Pk is basically is perpendicular to the plane of orbit or orbitals. So, this basically Pk direction. So, now this plane itself can orient it in any direction in space. So, now that is restricted. Here also it is quantized, that direction of Pk is quantized with respect to a fixed direction in space. So, if fixed direction in space is this generally the direction in which we apply magnetic field or electric field. So, this from this, so it is quantized. So, condition for this quantization, if it is phi, this angle is phi. So, Pk cos phi, this projection of this direction along this reference direction in space. So, Pk cos phi equal to, it is quantized. So, it will be such that orientation of Pk will be such that Pk cos phi, it has to be quantized Mk H cross. Okay. So, we have seen this cos phi equal to, from these two Mk by K. So, we have seen that K can take value 1, 2, 3 up to n principal quantum number, and for each k again Mk can take value, can take value, because cos phi can be 0, it can be maximum plus minus 1. So, from here as I described earlier, so Mk can take value minus k to 0 plus k. Okay. So, 2k plus 1 number of Mk value for a particular k value. Okay. So, this quantization is basically for a particular k value, if k value is say 2, for k value 2, so it can have different orientation. Now, which orientations are allowed? So, if this is the pk value, if this is one orientation, pk equal to k is cross, okay. So, its projection along this direction, along this reference direction in space, projection will be the 0. So, mk value basically is 0, mk value is basically 0, and then other direction. So, it's are allowed, it should be plus 1, it should be plus 2, okay, and minus 1, minus 2. Okay. So, these are the for k equal to 2 ml, these 5 values are allowed, quantized value along this fixed direction. So, that direction has to be such that the projection of this pk direction, it has to be plus 1 for mk, this value has to be plus 1. Similarly, this will be plus 2. This is another direction, okay. I think direction I should give projection in this direction, projection in this direction. So, projection direction. So, it's this type of diagram generally you can see in book, okay, to represent this space quantization, So, these are the possible orientation of pk, angular momentum in space. So, this is the space quantization. Now we have seen that if we apply magnetic field, if we want to explain the Zeeman effect. So, if we apply magnetic field in this direction, so magnetic field will interact with the atom if atom have some magnetic moment, and it is, we have seen that it has magnetic moment. We have find out this mu k equal to E by 2m pk. So, that is the relation we have seen, and now pk is k is cross. So, if I write this way, k is cross. So, this is defined by mu v, k mu v. Okay. So, mu v is the unit of the magnetic moment. It is called Bohr magneton, as I described earlier. So, now energy, when apply magnetic field, this energy, I have that energy due to magnetic field, is defined that mu k, if magnetic moment of this atom or electron is mu k, and if we apply magnetic field, so its potential energy will change this way. Okay. So, mu dot b, from electrodynamics one can get this definition. So, for mu k dot b, now this I can write, you see, angle between, so this now b direction, you know, this now b direction, this is now b direction. Now, this phi angle is between pk and this b, but mu k generally it is just opposite direction of pk, because this electronic charge here E, whatever this relation between these two is basically opposite direction, because this E is negative, charge is negative. So, that is why it is their direction magnetic moment and this angular momentum, that direction is in opposite direction. So, this will be, this is the direction of corresponding magnetic moment for this angular momentum pk, corresponding angular momentum mu k, they are in opposite direction. Okay. So, now the angle between these two is phi, so it is in opposite direction. So, you will get basically mu k, b cos phi, because this negative will go because of this opposite direction, 180 degree difference. So, now your this I can write mu k is basically I can write k mu v, b is there, and this cos phi I can write m k by k. So, ultimately I am getting EV, equal to m k mu v b, okay, m k mu v b. So, that is the energy of the system due to magnetic field. So, now in presence of magnetic field, what will be the total energy of energy level? Now, now this energy will be added. So, energy will be our, it was E n k, okay, plus mu v. So, that will be the energy, and that energy now it depends of n k and m k, okay, in presence of magnetic field. So, here I should use E n k, okay. So, that will be the energy of energy levels in presence of magnetic field. Now, you see, if I now I have energy level. So, it is for a particular n value, okay, there are different number of, there are n number of k value, okay. So, now if I take this 2 k, say k equal to 1 and k equal to 2, okay, k equal to 1, k equal to 2 before applying magnetic field, that was the energy according to this. Now, energy of this will be, it depends on m k. For each k we have how many number of L value, 2k plus 1. So, ml value will be 1, so this will be 1, okay. So, now its energy ml value will be 1. So, mk is 0 value. So, this energy of this will, after applying magnetic field, it will not change, it will remain the same energy, because mk is 0. So, this is mk, k is here 1, k equal to 1. So, this is 0 value. Now, for k equal to 2, k equal to 1, 2k plus 1, sorry. So, k equal to 1, it has to be 3. So, it has to be 3. So, this one is this mk, that is for 1, it is for 0, it is energy will be unchanged. Then when mk is plus 1, so mk value for k equal to 1, mk value is plus 1 and minus 1 as well as 0. So, plus 1, so energy will be up, and minus 1 it is more negative. So, it will go down, but it will go down by equal amount. So, this is mk equal to this is let's forget mk equal to 0, mk equal to minus 1, and another splitting of this energy line, so that will be plus 1. Okay. So, now this k equal to 1, this one energy level in presence of magnetic field, it is splitted into 3 lines. One is original and 2 more lines. Okay. And what is the separation of these two? This is basically mu v b, this separation. Okay. So, similarly from here you will get 5 line, it will be splitted into 5, original, and then two more, okay. So, here now mk value for k equal to 0, this is plus 1, this is plus 2, this is 1, minus 1, this is minus 2. Okay. So, now energy levels are splitted depending on the k value, 2k plus 1 in number, and one can find out what will be the energy. So, now there will be transition, following the here also selection rule is considered, mk equal to 0 plus minus 1. So, that is the selection rule, and del k equal to plus minus 1. Okay. So, here del k is 1. So, whatever the one energy, one spectral line, okay, del k is plus minus 1. So, now this energy level here, after applying magnetic field following this transition rule, if I draw, then you can see that if I start from here, so minus 2 to plus 1 is not allowed, because final to initial, if I take difference, plus 1 minus of minus 2, so it will be plus 3. So, this is not allowed, this also not allowed, difference will be plus 2, this is allowed, minus 1 plus 2, so it is plus 1. So, you will get this transition. Okay. You will get this transition if I start from here. So, here to here it is possible because it is 0, and then from this to this also allowed, this to this also allowed, and this minus 1 to minus 1 also allowed. So, you will get this. Okay. And then if I start from here, I will get this is allowed, this is allowed, this is plus 1 difference, and then this to this also allowed, sorry, this to this also allowed, with 0 difference, and you will get from here to here, this is also allowed, you will get it. So, this is difference delta m minus 1. Okay. Now, if I see from here, so I will see this plus 1 to plus 1, difference is 0, del mk is 0, this is allowed, this also allowed minus 1, okay, and this to this minus 1 minus of plus 1, this minus 3 is not allowed, and 2 to plus 1 means plus 1 minus of plus 2 means minus 2, so it's minus 1, so this will be allowed, this will be allowed transition, and then this to this is not allowed, this to this is not allowed, okay. So, how many lines I am getting? I am getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, something mistake, it should be 9. Just let us check it. So, if I start from here, so this is allowed, it is a delta, so del mk equal to, in this case, minus 2 to minus 1. So, basically initial to final is plus 2, so difference is plus 1. So, it is plus 1, delta mk is plus 1. So, this is allowed, and then if I consider from here to here it is allowed, from here to here, from here to here it is not allowed. Okay. Now, go to the next energy level, from here minus 1 to 0, sorry, minus 1 to plus 1. So, this is not allowed, minus plus 1. So, final minus of minus 1. So, plus 1, it is 2. So, that is not allowed. So, that was the mistake. So, this is not allowed, this is not allowed. This is not allowed because this is becoming plus delta mk plus 2. So, this check this one is difference is plus 1. So, this is plus 1 delta mk, this one is minus 0 delta mk is 0, this one between these two it is plus 1, this one is 0 delta mk 0, this one delta mk is minus 1, this one is 0, this one is minus 1, and this one is why this one I have done, this is not allowed, it is not this one, it stay here, it has to be here. So, plus 2 to plus 1, so minus 2, so it is minus 1, so minus 1, okay. So, these are the transition possible, and here you can look that for delta mk plus 1, how many are there? 1, 2, 3 lines. Delta mk 0, how many are there? 1, 2, 3. Delta mk minus 1, how many are there? 1, 2, 3. Okay. So, and you can see that for it depends on delta mk. When delta mk, so transition between two, if I in general if I consider that delta energy difference, okay, because of transition, that will be E n k m k, that energy level, minus E say n dash k dash in general m k dash, okay. So, that the energy difference and corresponding transition this spectral lines you will get, okay. So, if you take difference like this, so what you will get? The delta E, you will get, if you write this minus of this dash 1, so I will get E n k minus E n dash k dash, okay, this one, and then I will get m k, then let me write here m k minus m k dash, okay, and then mu v b, okay. So, this m k minus m k dash is basically del m k. So, this I can write del m k, okay. So, this is the energy difference. Now, if I divide by Hc, I will get lambda, because energy, what is the relation? Energy H, E equal to H nu, and nu equal to C by lambda, okay. So, if I divide it by Hc, so I will get 1 by lambda. So, this is basically nu bar, okay. So, I will get nu bar 1 by lambda if I divide by Hc. So, this will be divided by Hc, it will be divided by Hc. So, does not matter, okay. Now, the spectral lines, how many I will get, because this is the selection rule, del m k is 0, then nu bar I can write, nu bar I will get original one. So, this transition, okay, original one between these two. So, between these two I will get the original one. So, this whatever the original wave number of this one, so that I will get here. So, this for delta m k equal to 0, and then I will get delta m k plus 1. So, then I will get nu bar equal to, basically I will get nu bar, then this plus 1 and minus 1. So, I will get plus minus mu v b, okay, okay. So, here you can see this for delta m k, this original line, and two more line will get the wave number is just its difference by this mu v, okay, plus mu v or minus mu v. So, that is why whatever 9 lines we are getting, so their energy are not different, only the 3 lines are having the same energy, only 3 different energy of spectral lines we will get. So, for delta m k equal to 0, so this all 3 will have the same energy, because these have symmetry, this it is shifted by this by same amount, this mu b b, its splitting is in terms of mu b b, okay. This is 2 mu b b, 1 mu b b, here also 1 mu b b, okay. So, that is why energy of all 9 lines are not same, it is only we will get 3 group of lines. So, 3 lines of are having same energy. So, that corresponds to this for these 3, delta m k equal to 0, plus 1 and minus 1. So, you see here we have taken arbitrary k value, k equal to 1, k equal to 2, these are one spectral line for any in value, okay. So, these 3 lines, it does not depend on here also from expression you can see, okay, it does not depend on n and k, and even so only this restriction transition rule is followed, okay, it does not depend on n and k. So, we are getting any spectral lines having any n and k value, but under magnetic field it will be splitted into 3 lines, it will be splitted into 3 lines. So, as I told this called the normal Zeeman effect. Any spectral line under high magnetic field, it is splitted into 3. So, now introducing the space quantization, okay, we are able to explain normal Zeeman effect. So, that is very this is in that sense is very successful, but still introducing this MK space quantization, we are not still able to explain the fine structure of hydrogen atom and and sodium or alkali atom also, like sodium D1, D2 lines. What is the origin of that? What is the origin of 5 spectral lines of H alpha? So, these are the experimental fact and that cannot be explained, as well as anomalous Zeeman effect. In that case, it depends on the spectral lines, it depends on the NK value. Depending on that, one spectral line under weak magnetic field, it is splitted into different number. So, it can be 4, it can be 6, etc., but it is higher than the 3 energy levels, energy spectral lines. So, that was not also one cannot explain. So, again we are getting, so there are something left which will give more quantization and will be able to explain this observation of more spectral lines, as we have seen from sodium D lines, we have seen from H alpha line, and for also anomalous Zeeman effect. Okay. So, we need more quantization. So, I will discuss in next class. I will stop here. Thank you.